Assalamualaikum. So, our project is the development of artificial intelligence based optimal route selection tool for Peshawar traffic police and rescue services. Our supervisor is Dr. Imran Ahmad and I am Imtisal Ahmed Hashmi and my teammates are Muhammad Wasif Amjad and Samar Gul. Now, the literature review. Well, we have studied more than 20 to 30 case studies and we have shared the most related case studies to our project here on this slide, and other case studies are added to a file and the link is shared at the end of this presentation. Well, the first case study you can see is the threshold value based traffic congestion identification method, where they use three variables: occupancy, velocity and volume, and they determined the threshold value, and the congestion rules were extracted with the help of a decision tree. Well, the second case study is the traffic congestion and the long driving hours impact on the stress, emotional, physical health among the drivers in Sharjah. Here they observe the effects and the consequences of the traffic jams on the drivers. The other case study are simulation and optimization of urban traffic using AI, the survey on the traffic prediction techniques using artificial intelligence for the communication network model of urban traffic system using artificial intelligence, and how does the traffic behavior changes using sumo traffic generation tool. Well, the most of the case studies are related to AI and how AI can help to optimize and make the traffic system more efficient. And the last one is the related to the sumo software, which is the simulation of urban mobility. And here you can simulate the traffic and its various scenarios in this software. Well, now the first objective is to develop a tool to find the optimum blocking point for the traffic police. Well, due to any reason, if the traffic police want to block certain roads, they do not have accurate data that which point should be the optimal to block. They just block the road based on their past history or past experience. So we want to generate a tool through which they can see that if they want to block a certain point on a road, due to any reason, maybe an official is coming, maybe there's been an emergency, due to any reason they want to block a road, so they can see that how much traffic is diverted to the other alternative locations and what will be the situation on those locations, and especially the locations that are connected to the critical locations like hospitals, courts, etc. So they will know that if the traffic is diverted on the other roads, so whether they are making the congestion or they are producing the congestion or not on the alternative roads in the future. To implement machine learning techniques and simulate the results, to relate the simulation with AI and proper tool generation by Python software, to design a project that contributes to the welfare of the society. And well, here we consider the location, the zone of Khyber Bazaar, and we collected some data and we have observed that there is congestion on the most of the time, on most of the period on these roads near the Khyber Bazaar, and also a critical location like LRH is also situated here. The one you can see is the congestion and zero you can see is the flow. Well, this is a simulation of Deans to LRH Sumo simulation. Here you can see some moving cars that are moving from Deans to the LRH to the shortest route possible. Well, let's in the future we will block a certain point on this shortest route, and then we will see how the traffic will react and where on which route it will be diverted. Problem statement: the development of road infrastructure in the urban areas has placed an enormous pressure on the traffic volumes. The process of unforecasted blockages by the traffic police causes decreased flow rate, an increase in occupancy and on-road fatalities due to the late arrival at the hospital, and the project focuses on forecasting optimal blocking point and developing a tool to predict congestion on alternative routes due to that blockage. Well, the problem which we have selected is that due to the unforecasted blockages, the police or the traffic police don't forecast that where should they put the blockage. Due to that, the traffic is diverted on the alternative location, and that decreases the flow rate of the cars and increases the occupancy of the cars on the alternative routes, and due to which the different road fatalities occurs because maybe the ambulances didn't reach the hospital on the time, or the late arrival at the hospital. Due to these different conditions, many consequences have been faced. The project focuses on forecasting an optimal blocking point. Well, we want to generate a tool that will help them to forecast which the blockage or which blocking point or blocking node will be optimal, or will produce the minimum congestion on the alternative routes, or especially minimum congestion on the alternative routes on which the critical locations are present, like hospital, courts, etc. Well, this is our methodology. First, the system identification, then conceptual model and construction, data collection, development model using Sumo, validate, verification, generate results, embedding AI and algorithm testing, generate result validation and verification, online embedding results validation and verification, and documentation. Data collection, sampling. Well, we use the sampling techniques used as cluster random sampling techniques. We divided our data into different clusters, and then again divided those clusters into sub cluster, and then selected the data that represents the whole population density. Well, in our data the velocity and the flow rate was given, but the density wasn't given, and we were using the macroscopic model that is best to explain, or that is best to use in our project. So we calculated the density with the help of a macroscopic model equation, which is flow rate equals to density multiplied by velocity. The density and the flow rate have a high effect on congestion. Obviously, our model outputs are of classification as the results are of binary. So they are of classification as 1 is the congestion and 0 is the flow. We have applied different machine learning model to see how well our data helps a model to predict the results. Well, this is some statistics of our model. The total count is 1,559, and this is the mean. And here you can also see the units of these variables or parameters, and congestion has no variables, so the unit section is empty. After that, you can see the district wise on the spot death report data. Well, as we have discussed earlier, that due to the late arrival at the hospital, many deaths occurs. So in the last year in Peshawar, 709 deaths occurred, in Charsadda 31 deaths occurred, and in total KPK 3,300 deaths occurred last year. The total congestion points were 102, and total flow points were 1457. Here comes the data analysis. We have performed the Adrenson-Darling test, and the results were really good. So our data follows a normal distribution. Well, these are the different models which we have compared and used in our project, and have found the best model that will help us to predict the congestion prediction. That is the ADA boost model, whose F1 score is 0.99868. Data analysis. First, after selecting the model, that is ADA boost, we selected the hyperparameter, the best hyperparameters, and we did the hyperparameter tuning, and the best parameters were n estimators 250, learning rate 0.05, and algorithm SAMME. The best score for the best hyperparameter is 0.99868. After that, again we did the cross validation to check whether the results are accurate or not, or more whether they follow some unusual patterns in the data. To overcome that, we used the cross validation, and the score was the same. Here you can see the precision, recall, F1 score, accuracy, and support of our model on the when we trained our data, and after that we test our data on the test set. After that we get these values of precision, recall, F1 score, accuracy, and support. Here you can see some locations like Dean's Gate, FC Chowk, Ajabghar. Well, this is the shortest path from the Dean's Gate to LRH, and on the left side and on the right side, I have blocked a certain node on the map, and after that, our shortest path algorithm have generated this results. Well, the shortest path algorithm which we are using is the A star algorithm, which is an heuristic model. Okay, so this is our Gantt chart. As you can see that every line is green, which means we have completed our project and successfully done it, and we have achieved all our objectives and have created an online tool. Assalamualaikum. So final year project is the development of artificial intelligence based optimal route selection tool for Peshawar traffic police and the rescue services. Here you can see our project title. Down here is the map, and the purple line shows the region, the zone we have selected. It starts from the Dean to LRH. And here is the some data that the customer or the user has to give. This is the blocking node, the node which you have to block, the starting node and the destination node. The Here you can see the please select blocking node map to see which node you want to block from 1 to 22, as there are a total of 22 points or nodes we have selected. So we will select the blocking node map now. This is the blocking node map. Here you can see 22 nodes, and if you click on the node you can see the name of the place or the location when it is in. And here let's suppose we want to go from Dean's to the Lady Reading Hospital, which is the 14th point, and here let's block the 17th point, which is Kissa Khwani Road. So 17, and starting node is 2, which is Dean's, and the destination node is 14, which is LRH. Now let's see which shortest path our shortest path algorithm has selected. Here you can see the red point shows the block. Here was the 17th point, which was Kissa Khwani Road, so it is blocked, and the shortest path from 2 to 14 after blocking this point is this path. Here you can see an ant map which is moving from 2 to 14. Now here on the side you can also see the shortest path with names Dean's, FC Chowk, Ajibghar to all the way to Lady Reading Hospital. Now let's see the congestion. How can you see the congestion? Here, generate congestion predictions. Well, if you don't know, first time you're using it, down here you can see the predictions, the enter which has the 4 points. Enter your starting node which we have entered, destination node, blocking node is also entered. Now select the generate congestion prediction. Let's go on the generate congestion prediction. Here you can see some predictions. The green means that it is clear and there is no traffic jam. Well, down here you can see the select the data sets. Well, the data is 2 to 3, which means that from the point 2 to 3, which is the Deans to the FC choke, between this place it is clear and there is no congestion on this day. After that, let's suppose you want to see the congestion between this 7 and ninth point. Let's see how you can select that. There's a drop down menu here, 7 and 9. 7 and 9. Okay, here you can see again that this is the congestion prediction, and the red point shows that the traffic is blocked, and here you can also see the 1, and the 0 shows that the traffic is clear and it is slow and it's not jammed. The time of the day starts from 7 a.m. to 9:45 p.m. down here. And there are also some other details available, which is the probability of the flow and the probability of congestion. And down here it is also tells us that the 0 is the traffic is flowing and 1 means that the traffic is jammed. Let's see there are some other place. uh, let's select between this here 10th and 11th. Let's go here. And 10 and 11. When you select it, it automatically changes and generates some predictions for that specific area. And again, time, prediction, probability of flow, and probability of congestion. And you can also increase the size and visualize it more clearly. Thank you. So, this is our tool that we have made. Okay, now let's relate our project with the United Nations Sustainability and SDGs goals. Well, our project fulfills the goal 3, which is the good health and the well-being by reducing the traffic congestion, and which aims to improve the emergency responsive time and also helps the drivers. Well, as the traffic has the negative effects on the drivers as well. The second point our project fulfills is the goal 9, the industry innovation and infrastructure. The third point is the goal 11, the sustainable cities and communities. The 13th or the fourth goal is the climate action. Well, it also helps to make our climate better as there will be less traffic and less pollution. And the last point or the goal that our project fulfill is the partnerships for the goals. Thank you. That's all.